Hello guys, what's up? I'm Engineering AK and today we are um, starting the lecture 4, and it is the most I would say the important lecture of this chapter. Mostly the examiner give question from this topic uh, in paper. So let's get started. So packing factor. What is packing factor? Packing factor refer to the amount of space that is occupied by atom, ions or molecule in a crystal, right? Like if I am taking a unit structure, if I am taking a unit cell, so how many atoms are there in that region, right? Or how many space the atom have occupied, right? Or it is a measure of efficiency of packing of these particles in a given volume, right? For example, if I am taking a unit cell, so how efficiently atoms are closely packed. Like in previous lecture we have seen that the BCC structure contain 2 atoms and the FCC structure contain 4 atoms. So it is obvious that FCC structure is more closely packed as compared to the BCC structure. And now in this video we will mathematically see that is it true or not. Or we can also say it is the ratio of volume of atom to volume of cell, right? Packing, it is the formula of packing factor, volume of atom divided by volume of cell, right? So now let's first find the packing factor of the FCC structure, phase center cubic. So the volume of the sphere or cell, in this we are taking the atom, or the atom we are taking as a cell or as a sphere, right? And the volume of the sphere has formula 4 by 3 pi r cube, right? This is a sphere. Like I am taking one atom as a sphere, and we know that the total atom in our unit cells of FCC, we have seen that it was 4 atom. In previous lecture we have seen that it contained 4 atom total. So for finding volume of atom or sphere, we know that the volume of the one sphere is 4 by 3 pi r cube. So there are 4 spheres or 4 atom in FCC, so we will multiply it by 4, right? So it will give us 16 pi r cube divided by 3, right? So it is the volume of the cell. Now for finding the volume of the atom, it's a volume of the cube, right? So the volume of cube equals to, like this is a cube, this is a, let's suppose this is side is equal to a, so this will be a, and this will be a, length multiply breadth multiply height, so it's a cube. Volume of a cube is equal to a cube, right? Let's find this a cube and then we will plug in the values in packing factor formula, and we'll see that what is the packing factor of FCC structure. So if I am taking, let's suppose this is a 3D model, so let me show you what they have taken. So this is like we can see that there are one atom at the face, right? And this is the other atom, and we have in previous lecture we have already discussed that it is r, right? And this is the whole diameter, so it is 2r, and this is r. Like in this, if I see in this last diagram, so I can say that it is r, right? And if I am taking the second one, let me take it, so it's r as well, right? It's r, it's an, and in the middle one I can say that it's 2, and it's r, right? So it's R, 2R and 3, so sorry, so it's become 4R, right? 2R are these, R and R, so 4R, right? So this hypotenuse is equal to 4R, right? So if I am taking this triangle, right, this triangle here, and I want to find this, let's suppose this is A, I know this is A, right, this is A, so, and this is hypotenuse, I want to find this. So if I apply Pythagoras theorem, so hypotenuse is equal to base square plus perpendicular square. So hypotenuse is equal to x, as mentioned here, and base square plus perpendicular square, right, AA. And because it's a cube, sorry, it's a bit linear, but it's, I am taking this triangle, right, this one, so these both sides are equal as it's a cube. So it become x square is equal to 2a. Now if I taking under root both sides, so x is equal to a under root 2, right? But if I see in diagram, so this hypotenuse also equal to 4r. So let's compare these two, right? So x is equal to a under root 2 and x is also equal to 4r. So if I both side divide by under root 2, so I get this a is equal to 4r divided by under root 2. Now we will putting values in packing factor formula, and we know the packing factor formula is v is equal to volume of atom or sphere divided by volume of cell or cube. So volume of atom is equal to here we already have find it, 16 pi r cube divided by 3. So 16 pi r cube divided by 3 and divided by a cube, right, volume of cell here, a cube. Now plugging the values, so a is equal to 4r under the root 2, so I have putting a value here. Then if I take cube of 4, so it's become 64 and r cube and under the root 3 cube, right, whole cube. Now so if I simplify it, so it look like that, right, 16 pi r cube divided by 3 and multiply by like I have taking reciprocated, I have reciprocated, or you can take a reciprocal of it, so the divide sign can be changed into multiplication sign, right? So under the root 2 cube divided by 64 r cube. So if I solve it, yeah, so 16 ones are 16 and 16 fours are 64. This r cube will be cancelled out with this r cube, right? So we will be left with right, so I can say that here is under the root 2 cube pi, right, and divided by 3 multiply 4. I am left with this, like I have these terms if I mention it, okay. So here I just left with this pi and divide 3 and this whole term, right, and 4, right? So if I come down, so I get this pi d cube divided by 3 multiply 4. Now let's check it, what I get, right? So if I plug in the values, let me first clear it, okay. Now if I am taking under the root wait, okay, under the root 2 and whole cube multiply by 5 and divide by 3 multiply 4, so I get 0.74, right? So 0.74, right, and this is the packing factor of FCC structure, right? Now let's see the packing factor of BCC structure. So we know that the volume of the sphere of a self atom is equal to V is equal to 4 by 3 pi r cube. This is the volume of the sphere, right? And the total unit cell of BCC, we know that the total number of atom in BCC are 2. So if I want to find the volume of the sphere, so for one sphere is equal to 4 by 3 pi r cube. So there are 2 atoms or 2 spheres, so if I multiply by 2, so it becomes 8 pi r cube divided by 3, right? So this is the volume of the sphere or cell. Now for finding volume of the cube, let me correct it. Okay, so volume of the cube is equal to V is equal to A cube. As I told you, if I see this diagram, so A and A, length multiply breadth multiply height, right? So A cube. Now in this structure we can see, let's first see this red one, right? Let me show you. So it's going to start from this and it will pass through center and like that. Yes, like that. So it is moving from this corner. So in this structure, if we can see that these two atoms are the corners of these two atoms are touching the center one, right? So this line is passing through these two and the center of this sphere, this atom. And if we see its 2D structure, so it's look like that. We cannot simply take straightforward like in FCC, like in that, because there is no atom touching these two, but the line is passing through the center, right? Like that. So for that, let's suppose I am taking this triangle, this one, right, the green one and this blue line and this red one triangle. I am taking that. Let's suppose I am considering it as a triangle A, and the second triangle I am taking this one, right, this red line and these two blue lines. It's triangle A, and let's see, it's I told you that it will be 4R, same like FCC, R and 2R and this R, so it's become total 4R. Hypotenuse become 4R, so this become 4R. In 2D it's not touching each other, but in 3D model they are touching each other side, right? So this is 4R, right? And this is I am taking as, let's suppose, D. And the blue one, you know that it's a cube, so it's all same A, right? So 4R, blue one A, and the red one is D. I am taking as D. And if I am taking this triangle B, so D, this become D and AA, right? So applying Pythagoras theorem on both of triangle, so hypotenuse square equal to base square plus perpendicular square. So hypotenuse square I know is equal to 4R, right? It's 4R square equals base square, D square and A square, right? And if I further simplify it, to it becomes 16R square is equal to D square plus A square. And let's suppose I am naming it equation 1. Now coming to triangle B, so applying same Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. So hypotenuse D square is equal to A square and A square, so it becomes D is equal to A square. Let's put this D square in equation 1 instead of here, right? So if I plug in the values, so 16R square is equal to D square plus A square, and D square is equal to 2A square. So 2A square, it become, if it become 3A square, 16R square is equal to 3A square. Now both sides divide by 3, so I will left here with A square and 3 will come here within the divide. Now if I am taking under root on both sides, so A is equal to 16R square divided by 3 whole under the root, right? Or you can say power 1 over 2. Now it become, if I take under root on 16R square, so it become 4R, right? Under root of 16 is 4, and R square, the square will be cancelled with this 1 2, so R is equal to 3 power 1 over 2. Now putting the values in packing factor formula, packing factor is equal to V of atom divided by V of cell. So putting values of the both volume of the sphere and volume of the cell. So I find volume of the atom, that was 8 pi r cube divided by 3 here. 8 pi r cube divided by 3, right here, and divided by volume of the cell or cube is equal to a cube. Now 8 pi r cube divided by 3, and a is equal to 4r under the root 3. So I am taking whole cube of it. Now I am taking cube, so cube of 4 is equal to 64, right? And r cube, it become r cube, and if it multiply with this 1 over 2, so it's become 3 by 2, right? So now if I reciprocate it, so it become, the divide sign will be changed into multiplication sign. This will, or 3 power 3 by 2 will move up, and 64 r cube will move down, and it will look like that, right? And if I cancel out, let's see, okay, let me choose a color. Okay, so this 8 will cancel out with this 64, and here I just left with 8, right? This r will be cancelled out with this r, right? And we will left with the pi here. The terms that I will left with right here, just let's go. So here I just left with the pi, and here 3 power 3 by 2, 3 and 8, right? So let me plug in the values and see what we get. So I will left with the pi 3 power 3 by 2 and 8 multiplied 3, right? So okay, let me clear it. Okay, let me wait. Let me wait, or okay. So here this 64 and 8 cancel out r, so here I just left with pi multiply by 3 power 3 divided by 2, right? And here this 8 cancel out with this 64, so here I am just left with 8 multiply 3 multiply 8, so 0.68. what I get, 0.68. So this is the packing factor of BCC. So here, from here, as we have studied before, that BCC structure contain 2 atoms, so it is not that much densely packed as FCC, because FCC contain 4 atoms. And here we see the packing factor of BCC is 0.68, and for FCC it is 0.74. so now we are clear that FCC structure is more densely packed as compared to the BCC structure. And thank you for watching, and see you in next video. Thank you.